And tonight we're going to do something a little bit different. But first, it's going to be all about electromagnets. So, to make an electromagnet, where did I put it? I just had it. Oh, here it is. Basically, you can just get a nail and wrap a piece of copper wire around it, and then sand down the edges so that it conducts, and that will basically make an electromagnet. And this is kind of a cool little effect. But basically, all wire, or pretty much I think everything electrical, will generate a small magnetic field. This is kind of a way of concentrating that magnetic field to make it pretty cool and useful. But it comes into everything. So tonight, before we get on to what we're doing tonight, this is a demonstration. I've got this one all set up. So here we go. Here is a very mangled paper clip, and we're going to use this thing. So it's all set up to the battery. I wired up a circuit so it goes through this little button into here and through here and back out here. So basically you want as much current to flow through this as possible to get the maximum magnetic field you can, though it does tend to heat up and you don't want to do this for too long, which is why I have a button. But as you can see, this thing does not pick up my mangled paper clip. But if I activate the button, it does pick it up, and then I can hold it up in the air just like that. No magic, no strings or anything, and then I can let go of it and it falls to the ground. Pick it up and falls to the ground. Pick it up, falls to the ground. Kind of. So it gets a bit sticky sometimes, because I think after a while there's a sort of residual magnetism inside of the nail. So if you ever get a magnet and you rub it up and down a nail, so I have a pile of magnets over here, if I was to rub this up and down the nail, it builds up its kind of own residual magnetism that lasts for a little bit, and that's I think why it sticks like that. I forgot the name of I was supposed to look up the name of the term for that and what kind of materials they are. This little bit of hair keeps getting stuck everywhere. So anyway, given this, which is kind of cool, kind of interesting, I was looking around at an op shop like I always do, and I came across this thing here. So this is the Ensemble Experiment. It's got English on one side and French on the other one, which maybe it's just mainly got non-English. So the point is, it's these little kit set things to make an electrical item, and one of them is a light with a little key switch thing, and the other one is a bell, an electromagnetic controlled bell thing. So I thought this was actually really cool, and sort of shows a nice interesting application for this. I was hoping actually when I looked at this that the bell would ring continually, and we're going to talk about how that worked. But I think it only goes ding when you press the button, and then it's only dings once every time you press the button, and you have to let go before it will ding again. But we're going to find out, because I haven't actually built it yet. So, and I don't know how long it's going to take to build, so this might be a terrible video. It might be a two-parter, because as you will see, so, oops, oh no, please don't I tried to make sure that all the parts were in the box. So I'm going to put that carefully down there just in case I've lost one. So those are the instructions, and you may notice that this is the base for the bell part. But if you remember the box, it was actually the light part, and the trick is, I've already done that one, so I built that one up just to see how tricky it would be, and the answer is it's quite fiddly. The interesting thing here is this LED doesn't have any current limiting resistor, so I don't know if that's because it's a special one or just because they're relying on the limitations of batteries to supply current to this. But I can't see any other way that the current gets limited. But given that, when you press the button, it does come on, but it's not very bright. So it's possibly something to do with this particular LED. So I was thinking about changing one over to this kind, to one I just got sitting around, and seeing if that works. But of course what I could just do is put this on a breadboard and shove two AA batteries and see how it behaves. But anyway, that's that bomb built up. We're going to need this for later because the other part's going to attach to this. But I'm going to put this to the side, and we're going to try and do this. Now this is going to be kind of tedious, so it might be a two-part. I might just skip the middle bit. But here are all the important bell things, so we'll put that there. this is instructions we don't need, and these are the instructions for building the bell. So there you go, there's the instructions. The important thing is, the first step was, I'm not going to leave the instructions in front so that you can read them because there's not much point, but I am going to have them in front of me so I can read them. So that, I think, is a fair compromise. Let's go with this. It says cut a 6-inch length of enamel insulated wire. So that's this here. So the trick with copper wire is the kind of wire that you want to use. So you can get different ones. Like I think, wait, which one? So I've got some little random spools here. This one I got from the craft shop. It does not, I don't even know if it actually is copper or if it's just coloured copper. But it doesn't appear to be coated in any way, so it's conductive the whole way through. So it's not, it doesn't have any insulation on the outside. So if two bits of these wire, this wire touches another bit of that wire, then the electricity will conduct through it. And you don't quite want that. You want this. So on your nail, you don't want these wires to conduct with each other. You want them to be some insulated and kept separate from the nail and kept separate from themselves, so that the electricity has to flow all the way around all the little coils, all the way to the end, and it can't just do a shortcut and run across the top kind of thing. So this kind of wire, one of these ones, this one here anyhow, I think this one is actually coated. I've got varieties of other ones, but those happen to be the ones that are sitting right next to me. Well, this one here definitely is, because it came in the packet. So this one has like this enamel coating on it, which you can't really see. But the important bit is, where it does have to connect with other wires, you have to sand it down. So the first thing it tells me though is I need 6 inches. This is a lot of wire. So I'm a bit concerned that this is going to take way too long. And I don't actually see how to get this out. Okay. So this will be a two-parter. This will be a very fiddly video, but we might as well make a videos. People are saying, well, why don't you just edit things? Because I don't want to edit things. Because I haven't set up the computer that I was going to do the editing on. So I haven't got around to that yet. Which is terrible, but I have no subscribers to this channel and nobody watches it. So what's the point of doing it professionally? So when I get lots of subscribers and there's enough interest, then yeah, of course I'm going to start editing things. But right now I just want to get these things done. So it says 6 inches. That's not a lot. So I'm not even entirely sure what 6 inches is, because I don't live in a silly country. I live in a sensible country that doesn't use inches. And I have a ruler. But then, having said that, I was going to say, well, most rulers you get in New Zealand still have inches on it. Where's my little red one gone? Little red ruler. Well, anyway, it's 2.5 centimeters for an inch. So what's that? So 6 times 2.5 is 15 centimeters. So, which makes sense. 6 inches is half a foot, and a foot's about 30. So it's about that long. Alright, so we need to cut that bit off. I can't believe that ruler doesn't actually have inches on it. Weird. Okay, so we've sliced that bit off, and then it says I have to sand down the edges, and they give you a little bit of sandpaper, so that's kind of cool. It's a very small bit of sandpaper, so I better not muck this up. And if I do it on the white paper, I might be able to see the sanded off bits, but I can't. So, oh, you can. Look at that, I made a big mess. But that might just be the sandpaper. So, who knows? And then the other end, I think it says about 1 inch off on each end. So, I'm doing okay. When it comes to, you know, American measurements, like inches, actually I am, you know, everybody kind of knows what an inch is. And we all kind of know what a foot is. We sort of know what a yard is, and we know roughly what a mile is. But if you ask me what an ounce was, I still haven't a clue, really. Like an ounce feels to me like it should be a small quantity, like a gram. But it's not. It's bigger than a gram. So anyway, which I think it is, I'm pretty sure it is. Alright, leaving about, okay. Carefully wrap, alright. And then we have to do the same thing with this one here. So that bit goes in the little thing. So this is the long bit. So this is a lot of stuff to wrap around the spool. But once we've got that bit over, the rest should be pretty straightforward. Oh my goodness. I can never tell. Like, I guess you can kind of tell. It's not as shiny once you've done it. Whether or not you sanded it. And it's because it's very fiddly wire. This is incredibly fiddly wire. Should be doing this kind of stuff for. Like, it's obviously not fiddly in terms of normal wire you'd be using to do electronic stuff with, but it's fiddly in terms of I actually have to sand things down. This uses much thicker wire and it's slightly easier. If I was really cool at this, I'd be able to say what gauge wire this is just by looking at it. But I can't. It's 30 gauge probably, I don't know. Cough cough. And so now, carefully wrap the long piece of enamel insulated wire around the spool, leaving 4 inches unwound at the end and about 10 inches at the end of the wire. Well, route each of the wires through the separate holes in the spool side. This is symmetrical, so I don't think we have to worry about that. We just have to, these are the two, I'm assuming these are the 2 holes, but there are 2 holes here, so that means these 2 holes here. Alright, so this is going to be the fun part. We're going to have to think of some serious things to talk about during this phase of the thing. So I'm just going to go, so this will be the 4 inches. Is that 4 inches? That's not 4, it's way more than 4 inches. Well, we can be a little bit over the top. Maybe I should actually just put it through the hole first. And I guess we're going to use that. Ooh. And it's always easier to knot it up, and then I feel bad like I've done something wrong. But too late now. So I think I don't. Whoa. Okay. Fiddle, fiddle, fiddle. Let's do this. So hopefully we can just get into a quick rhythm. People always do this with, like, they put it on the end of a drill and then they just get the drill to do things. I think it's going to overlap. So it's overlapping. And there's kinks in the wires. See on the videos, they're always like, you have to get rid of all the kinks. Well, I can't. it's just not gonna happen. So we're gonna see what happens. There's no way that you can do this without them overlapping. So, well, you could, but oh man, you can't. They can't possibly fit. So they're gonna overlap. I don't think it matters. I don't think it should, because they're very, very close together. All this theory about magnetism, I haven't quite got it yet. Oh, I shouldn't go like that. It should be very fine. And I've got to. I think I should be like. I don't want to do like a sharp turn across like that and go from one side to the other. It's got to be a smooth, gradual backwards and forwards across the. Maybe it should have all been like. Oh, I don't know. Well, we'll find out. If it doesn't work, I'll just undo the whole thing again and restart. Obviously. Like, what else would I do? Well, I could never touch this thing again. So we did it this day I did with kids, try and build little motors. That didn't go well because it's very, very, very fiddly. But having said that, I've got another cool little set that we're going to do very soon, I hope, which hopefully will let me fulfill my dream of actually finally building a functioning motor out by hand. And it seems to work the way that I thought might be a better way of doing it. So all the little build it out of corks and stuff tricks don't seem to work very. Oh no, the wire's all messed up here. This is just going to be a video of me doing this. This is seriously going to take way too long. Oh, and I messed it up. Oh gosh. Oh, it's a nightmare. That solved nothing. Like, I literally, that was all me moving around for no reason. So that's, it's got messed up with the other bit of wire. So we need to, I thought I had, no, it's gone around here. Oh, what did I do? How did I get it like this? Oh no, we can't have that. Oh my goodness. Oh my goodness. How did I get like that? Oh, look at what I've done. This is bad. How am I going to get this? Oh. Oh, this is terrible. But I kind of started the video now. I can't just say, oh, well, I give up. There has to be a way of getting that to pop over the edge without me having to undo the whole thing again. So this bit somehow got caught over the top. It's very close to being able to pop back over again. But then it's going to be too loose. Oh, oh, that's so depressing. Oh, this is... Oh, oh my word. Oh my word. Oh my word. Alright, hold on. It can't have been too far back. Surely I noticed that beforehand. Alright, I'm going to move away from the camera because I'm slowly moving this out. And... Oh dear. Oh dear. Oh, we did it. We're back in. So now, since I've taken all the wire out, we're just going to do it real fast. And zooming. Don't do that again. I've got to pay real close attention. So I want to get the bit at the side. There's lots of kinks in the wire. Don't care. It's just nobody has the patience to get rid of all those unless you're a machine designed specifically to do this. This is what is my purpose in life: to spool copper on things, on spools. What's the term? This is winding copper on spools. And then they're like, oh my goodness. That's right. Deal with it. Join the club. Okay. So we're coming along. The wire on the side is looking like a bit of a mess. So you kind of think that they should have given it to you on a little spool that you could have just unraveled it from instead of just in a big clump. And then you'd just be transferring it, and then you feel like it was so tedious. It's like, what, you mean I'm taking it from this spool and putting it onto this spool? You've got to be. That's it. That's life. That's basically, you know, your future career, everyone's future career. It's taking the copper wire off one spool, putting it onto another one. It probably says something I should have read in the instructions. Oh, these kinks are getting worse. No, we can't have them like this. Oh my, there's no way to undo that one. Oh no, we did it. It's undone. Okay, a mild kink is fine, but that's far too big a kink. We can't have it like folding over by itself, if that makes sense. So we're about, I think, 2/3 of the way through, and I like the bottom bit's really not getting enough copper. So there's got to be a trick to get the bottom bit having a bit more copper. And then we'll slowly go back. So we've got that much left. That actually looks more than I thought it was. And then we're going to go slow. Oh dear. Okay, and now we're at to this point where there's a bit of a mangled. Oh no. Distress. This is not the kind of thing you should do on a video. Gosh, it's all got worse. So I probably should have stuck this. So mental note, next time, stick it on... Oh, stressed out. We're going to get to the point where I'm just going to say, okay, we're cutting the video here. That was the end of part 1. We're going to come back in a few weeks later on when I've got up the strength to do this whole thing again. But, oh gosh, oh my word, this is going to give me a definite sense of accomplishment once this thing is finished. Okay, so if we just keep doing that and don't pull too hard, and then we've got to thread this through this mess that I've made. It was going well, and then it all stopped going well, and then it started going bad, because that's what happens when things don't go well. Which is unfortunate. You think they'd have other options. All right, so all right, we've got a bit more. This thing has got to stay out of the way. I'm glad I put it through that hole. I think that was a wise decision. And I just crossed over real fast. It doesn't matter. It'll be fine. All right, and I don't actually know where the copper wire is coming from because it's all a mess, but it's still coming into my hands. So we're going okay. But I would... Okay, we need to somehow stop this bit from unraveling. So I'm going to put my expensive soldering iron. No, we won't. We will use. Speaking of soldering irons, I've decided to switch to lead-free. So I know there's a lot of people who do like electronics channels. They're all like, "Oh, I'm going to stick with leaded solder. That's the way to go. That lead-free stuff's terrible." But it's got lead in it, and it's not good for the environment. And so my major problem is not so much my health, like because I wash my hands after I use it and all that, and I don't eat food around around my soldering. But ooh, don't do that. That was it's got to stay there. Got to keep that bit a little bit manageable. What are we up to? Is that, well, yeah, it's fine to say that you're not going to get sick from the lead, but every time I do soldering, there's always these little bits of lead, and then where do I put them? Do I throw them in the rubbish? It's like, well, I mean, I guess I can, and it's basically what I end up doing, but you know, I have to clean my desk and wash my hands, and little bits of lead get into the water, and it's just like, I don't want to do that. I don't want to do that, and I'm just going to get lead free, because obviously people have decided that lead free is the way to go, and I don't really want lead in my diet or anywhere near me. And so yes, it is harder to use, and so if you're starting out soldering, if you haven't done any soldering before, it's probably easier and better on the morale and sense of self-worth, sorry, to use leaded at the very beginning, because you'll get somewhere with it. But once you get good at it, well, not that I'm saying I'm good at it, I'm terrible at it, but I'm slightly better than I was when I started. Oh, no, all my hard work. Well, we're running out of things now. Then you should be able to do it. You should be able to cope with the fact that it's a bit harder to work with, and that you have to have a higher temperature, and you've got all your stuff. So, you know, stop complaining and just use it, because that's what the regulations say we have to use now. It makes a lot more sense. It's better for the environment, better for our health. So, you know, so I always feel like this is me ranting. It's like, well, if you've been doing it for years and you're really good at soldering, and you're like a pro electrician person, it's like, well, just prove it and just use unleaded solder, and show us how good you are by using unleaded. Stop trying to be like, you know, I'm all tough because I use lead. I don't care. You know, it's all just like a conspiracy to you know, I'm not afraid of these things. So, well, maybe we should be afraid of lead. Even if, you know, in general, you're not going to get sick from doing leaded soldering, as long as you take reasonable precautions like washing your hands and not eating at your work area. But still, think about the little leaded waste you're creating. And I don't want to flush lead down the toilet or the sink. Okay, we're actually almost at the end of this. How much have we done? Oh my goodness, this is 30 minutes. This really has been. We've got 5 minutes left, so I have 5 minutes and I have to actually get this done. And then we're going to do another 30-minute video of me doing the rest of this thing. So I'm glad I did the LED bit first, because with that I might have actually made an interesting video. There was a few interesting things there. They want you to wire it up so that the red goes to the positive terminal. I mean the negative terminal, and then they wanted the black one to go to the positive terminal, and I thought, well, that was a bit strange. So maybe it's one of these slightly dodgy educational sets, like the INO ones. So there are some videos about these INO sets done by other much better electronics channels, and where it's been determined they aren't very good, but they are kind of interesting. And I happen to have one, and we're going to do it at some point. It's a slightly different one to I think I've seen the other ones, but it works pretty much the same way. Okay, so don't mess up this, and then we'll be done. Oh my gosh. Oh, alright. So, okay, hold on. We have got 4 minutes and 14 seconds according to the clock on my camera. Well, it's not the clock, it's how much time you have left before I decide to arbitrarily cut out and And so this is all the EU's fault, right? The whole thing. The EU's like, you know, no lead. And so, and they're also like 30 minutes limit on your non-actual video camera. So there we go, it's all their fault. So you could say yay for Brexit, but we won't, because we're not going to get political on this channel. But when you've just spent 20 minutes trying to do some silly wiring stuff, well, what else are you going to talk about? The weather. Like, the weather's been very warm here and nice, which is good. It was a bit cooler today though, so that was good. But I always feel like when it starts to get a bit cooler, you're always like, oh, it's far too hot, I hate this weather, I hate this weather. Gets mildly cooler, it's still very warm, and you're like, I missed the hot weather, I want it back again, it's freezing, I can't do this anymore. Or maybe that's just me. Okay, we are almost there. We have 3 minutes left on the clock. Oh, that's a big kink, but I don't care. And we are back at, it did say 10 inches, right? So we have to, the good thing is you can unwind it a bit. That's 10 inches. No, it's not. That's 10 inches, isn't it? Well, it can be one more. One more. There we go. Let's play it safe. What's going to be the worst thing that will happen? The magnetic field will be slightly too... Okay, what did I do with the sandpaper? So we're going to finish it off by sanding it here. That was a terrible electronics video. Well, if you don't like it, don't watch the whole video all the way through. Maybe I'll put a disclaimer in the description. It's basically just me winding copper. And we're done. And with 2 minutes to spare. So that's pretty good. So anyway, we will continue this. Now we've got this part out of the way. Hey, does it work though? We might have just enough time to find. We'll put this little thing in the middle, and we'll put that there, and then we'll replace this one with these wires, and we'll put this in here, and we'll see what happens when we activate it. We've got 1 minute and 38 seconds to do this. Can we do it? Where did I put my paper clips? Is this going to be better than my nail? Possibly it will be. Alright, so here's my paper clip. I have to kind of hold it like this. So you're going to have to trust me. I'm going to say if it's magnetized or not. It is! Whoa, look at that. It's even pulling the thing out. Wow. Can you even see that? Okay, hold on. So we're going to put it like this. And we're going to hold it very loosely here. And I'm going to press the button. And it's pulled it. And in fact, it's kind of cute. Which I suspect will play into this. So if I put this out like this. Ready for this? Okay, it's not going to work. Oh! It didn't quite work. Okay, we have 51 seconds. We can do this. Okay, it's going to sit there, and we're going to push the button, and it goes back in like that. Now that's cool. That almost makes that painstakingly horrible... Oh, it's coming in down a bit. Job of winding that worth it. So thanks. Like, share, subscribe. Sorry you had to watch all that. And next time we'll finish this off, and hopefully we'll make a cool little dinging bell thing. So thanks. Bye.